When we say that cross-chain transfers with USDC are fast, even nearly instant, how fast are we talking? And how is it possible? Welcome back to Stablecoin 101, a series by Circle where we break down the foundations of stablecoins and how they are powering the new internet financial system. My name is Blessing and I work on Circle's developer relations team. If you need a refresher on how cross-chain transfer work, check out our previous video on the interoperability of USDC. Traditionally, moving assets off Ethereum involves a lot of waiting, several minutes or even hours of confirmation time to be absolutely certain that the Ethereum transaction has been processed and won't be reversed. CCTP standard transfer requires waiting for the source chain's finality around 15 minutes on Ethereum before issuing the attestation to mint on the destination chain. That's already a huge improvement in safety over risky bridges, but the user experience is nevertheless slow, especially for a digitally native process. The newest feature of CCTP changes the game by introducing an optional fast transfer mode that makes transfers like Alice and Bob's truly near instant. In fact, CCTP Fast Transfer can reduce cross-chain USDC transfer times from 15 minutes to mere seconds. Talk about fast. How is CCTP Fast Transfer achieving this faster-than-finality magic? First, attestation before finalization. In CCTP, the attestation service, called Iris, doesn't always wait for the full finality on the source chain. Instead, if a user opts for a fast transfer, Iris will observe the burn event on the blockchain, Ethereum in our example, and after just a handful of block confirmations, about 16 seconds on Ethereum L1 in practice, it will go ahead and sign the attestation, even though the block isn't fully finalized yet. By attesting before the full block is finalized, CCTP Fast Transfer can release the message for Bob's funds to mint on Avalanche much faster, without waiting for the full 15 minutes. From Bob and Alice's perspective, if we forgot, Alice is the developer of a multi-chain wallet application. The transfer completes in a few seconds. This is what we mean by faster than finality. The system doesn't magically break the laws of blockchain physics, but it cleverly walks ahead of finality while still keeping safeguards in place. Second, Fast Transfer Allowance. Of course, one cannot simply ignore finality risk without a backup plan. What if that rare event happens and Ethereum does reorganize or double produce a block? Reversing Alice's 100 USDC, born after Bob already received his 100 USDC on Avalanche? In that scenario, it would seem like a new USDC was minted without a corresponding bond, because the bond didn't actually reach finality. CCTP Fast Transfer helps counter this reorg risk by introducing a concept called Fast Transfer Allowance, which is a reserve buffer that mitigates reorg risk by ensuring fast transfers are fully backed in the event of a mint for which the associated source chain bond is affected by a reorganization. This allowance mechanism supports faster than finality cross-chain transfers without compromising security or collateral integrity. New smart contract V2. To enable these features, Circle deployed a new set of V2 smart contracts on each supported chain, for example, Avalanche and Ethereum. These include Token Messenger V2 and Message Transmitter V2, which function similarly to their predecessor, but with support for the fast transfer workflow. For example, on the source chain, when Alice's app called Deposit for Burn on Token Messenger V2, it not only burned the USDC, but also specified the desired transfer speed, fast or standard. The message that was emitted included extra metadata, such as a minimum finality threshold and a timestamp, which Iris uses to determine how to handle the attestation. On the destination side, Message Transmitter V2's receive message function is capable of handling both finalized and pre-finalized or fast messages. It will only release funds to Bob if the attestation signatures are valid and meet the required threshold. If fast transfer was used, the contract knows that the fast transfer is coming in under the allowance safety net. All these contracts are on chain and open for developers to integrate with. Hooks. Another new feature of CCTP, though a bit beyond the basic transfer, is something called hooks. Hooks allow developers to trigger automated on-chain actions when a cross-chain USDC transfer completes. We've got swaps, deposit, or custom contract calls. Let's take a look at an example to understand what that means. Imagine if Alice not only wanted to send USDC to Avalanche, but also wanted to immediately deposit it into a DeFi protocol or execute a trade once it arrived on the destination chain. Hooks could enable that kind of one-step atomic action. While hooks are a bit more advanced, they underline the theme that CCTP isn't just about moving stablecoins, but about general messaging and faster programmability across supported chains. Let's review just how far CCTP has taken us by combining faster-than-finality cryptographic attestations with a robust collateral mechanism. CCTP Fast Transfer gives users the convenience of near-instant transfers without introducing new trust assumptions beyond Circle. There's no need for peer chain liquidity pools or wrapped tokens, which means better capital efficiency and unified liquidity for USDC across the ecosystem. And because everything is handled by smart contracts and signed messages, it avoids the pitfalls of traditional bridges that require extra trust or are prone to exploit. If you want to take a deeper dive into the use cases and technical insights of CCTP, join me as we look at some code examples in the next video. I'll see you there.